because these ag water standards that are in the new Food Safety Modernization Act, turns out they're relatively complicated for a lot of people, even for us as educators, even for some of those regulators that Wes was talking about working with for some of these readiness reviews. And I usually, in my office, I've been working at Cornell for almost 6 years now, I usually get one of two calls. It's either a question about water testing or a question about audits. More so about regulations now that the regulation is out, but agricultural water is by far one of the topics that I think growers struggle with the most, especially when it comes to the audits and what are you supposed to test for, and now with this whole regulation, this has become a big issue. So if you weren't aware, or if you're planning to go to the training that Wes and Meredith are holding tomorrow, the Food Safety Modernization Act was passed, a few years back. The first compliance dates for the largest growers are coming up next January, which is pretty quick. And this is the first ever mandatory regulation for the production of fresh fruits and vegetables. For those of you who have participated in audits prior to this, in my opinion, it's not all that much different. There's a few key things here, especially with the ag water stuff, but I'm about to tell you some things that might make you a little bit happier about that. But in general, this is good agricultural practices. If you've ever been to a GAPS training with anybody from New Jersey, you've seen a lot of this stuff before. And I mean, even these terms, biological soil amendments of animal origin, that's a scary term. That's an FDA term for manure. But all of these things are things that you've seen before that are in the regulation. But what I wanted to particularly focus on in this talk was the subpart E, the agricultural water requirements that are in the regulation. I sent a panicked email to Meredith on Monday or Friday, I can't even remember, because last week, interestingly enough, we were on a call. We work directly with FDA, so we're a cooperative agreement with FDA and USDA. So we work with the FDA produce safety staff, and we became aware that there was a news article published that came directly from FDA Commissioner Stephen Ostroff that said, FDA is looking to simplify water standards aimed at preventing produce contamination. And when we brought this up on our phone call with the FDA, they didn't deny that this was happening, that some of those water standards that have been published in the Federal Register are likely to change. We've been informed not to spend a lot of time updating our educational materials yet, because it sounds like they're going to be making some pretty drastic changes to those specific requirements because they're getting feedback. FDA and the state departments of agriculture are getting feedback that they're pretty complex, and farmers are not necessarily mathematicians, they're not expected to be microbiologists, and some of the stuff that are in those regulations, statistical threshold values, geometric means, those are pretty high-level things to be asking farmers to do. I'm not saying that you're not capable of doing those things, because you all absolutely are. There's tons of tools that will help you do those things. But they're getting a lot of feedback from farmers and from advocacy groups that say these water regulations are going to be really onerous. So I basically flipped my talk around, because what I had planned to tell you about was all the nitty-gritty details of the ag water regulation component of the produce safety rule. And I'm just really, at this point, I'd rather wait and see what comes out in guidance documents or what comes out from FDA before I go into all of those details, and really talk more about what is actually going to reduce risks on your farm with your agricultural water. If you are interested in what is in the regulation because you don't think it's going to change, or for whatever reason, the proceedings that I put in that booklet go into great depth about how you develop your microbial water quality profile, how you take the tests, what tests are you supposed to be testing for. It's a really great document. So if you're still interested in that, I do encourage you to look at the proceedings. Wes and Meredith are going to talk about it tomorrow still, because it is part of the standardized curriculum. But I'm here to tell you that I think things are going to change a little bit. And what I'm going to try to outline here is the things that I think are going to remain the same, because there are some basic principles that I think when you look at overall what's going to reduce the risk on your farm, that you can still implement without going crazy about the number of samples and doing all of these high-level calculations. So that's what I'd like to do today. In general, when you look at the data from foodborne illness outbreaks, like Jennifer was mentioning, a lot of those we're not able to actually track. Produce especially is really difficult because if you think about produce, it moves really quickly. It doesn't stick around in your fridge very long, hopefully not. People eat it, and then it's really hard to track foodborne illnesses back to produce. But when you look at some of the outbreaks that we do have data on, agricultural water, specifically irrigation water, production water, and post-harvest water have been identified as key routes that produce can become contaminated with pathogens. And when you actually look at the farm environment, water is unavoidable, right? We have to have water to grow produce, or else we'd not have any produce. So there's a number of ways that growers use water on the farm, everything from irrigation to fertigation to your pesticide sprays. Out west where there's droughts, they use it for dust abatement, which could actually contact the produce, and I've seen that firsthand. So there's a ton of different ways where you might have actual contact of agricultural water with fresh produce that could contaminate it. In general, the two biggest areas that you should be focusing on are what are you doing for your in-field water use in terms of what are you using to irrigate, for your fertigation, for frost protection, and then what are you doing, if anything, for your post-harvest activities? I know some growers aren't washing their produce at all, they're not cooling their stuff, it gets field packed and out the door. But for some of us, especially if you have a packing house, post-harvest water becomes really important because that's the final step of which water could contact that entire crop, and like Jennifer was talking about, cross-contamination can become a big issue. If you think about a big tank of water and you've got produce coming into that water, got a couple of pieces that have bird crap on it, that bird crap is now not just on 1 or 2 apples, it could be on a lot of apples if you don't have proper sanitation in that water. So you can see how these small issues can actually become really big problems because water is such a great mechanism for spreading that kind of contamination around. The 3 main things that we feel that you should focus on in terms of risk reduction would be, first of all, think about your production water quality and source. And we're going to talk about each one of these. Talk about the application method. What are you doing to actually apply the water to your crops? And are there opportunities for you to move to a different application method to lower your risks? And then the timing of application. And that goes towards some of the die-off stuff that I keep on referring to here, because you teed it up so nicely, all of those nice graphs and the science behind it. But we know that pathogens can die off over time. So if you extend that application period, you're going to be better off long term. So looking at the actual different types of water sources that many of you have on your farm, it ranges from lower risk, i.e. if you're on a municipal system or some type of public water supply, that's going to be treated. And usually you're not going to have any microbial issues. I'm sure we've all heard about like Flint, Michigan and having lead in their water and other chemical contamination issues, but generally if it's coming from a municipality, it's being treated for microbes and it's more likely to be safe. When you start moving in this direction, you start getting into some higher risk water sources. So this one in the middle is actually a really large wellhead and then just a stream. Can anybody give me a reason why those might be higher risk than something like a municipal? Yeah, exactly. It's open to the environment. I mean, especially these surface water sources, it could be impacted by a number of things. It could be runoff from your neighbor's farm. It could be, something, a sewage issue, even some of the groundwater sources. In New York, we have shallow wells. And when you have shallow wells and then you're in a drought, you tend to see water quality issues with wells, or if they're not properly constructed. Those are where you start running into some bigger issues. So think about what kind of source you're on and what kind of risk that poses to you. But in general, which one of these sources, A is a pond, C is the municipal, and then B is the well, which would be more variable in quality over time, A, B, or C? Yeah, it's going to be the surface water, just for the reasons that he pointed out. All of the impacts, it's open to the environment. You can't expect that you're going to be able to fence every single wild animal out of there, or even human impacts. One great example, and this is a true story, I had a grower that I was working with that told me they had a spike in their water test, and they actually went out and investigated. Turned out that found some gutted deer in his pond because he had allowed some people to hunt on his property, and they were gutting the deer, dumping them into the irrigation pond, and then hoofing out with the deer. And that caused a spike. And those are things that you're never really going to anticipate unless you know people are gutting deer and dumping them into your ponds. So just think about your water source and what kind of risks might be presented from that. The second thing to think about is your actual irrigation method. And when we were actually developing this curriculum, it was interesting when we asked people about these different irrigation methods, overhead, flood, or drip. People had a million names for them: trickle, subsurface, micro, undercanopy. Everybody calls it something different. But generally, if you're using overhead irrigation and it's going to contact the edible portion of the crop, it's going to be a higher risk application. So something like leafy greens and you're spraying it overhead. If you move towards flood or surface irrigation, lower risk just because you're not as likely, at least if the crop is up off the ground, if you've got staked tomatoes or something up off the ground, a lower risk application. But for things like root crops, obviously that water is going to contact things like carrots or potatoes. And then for drip irrigation, this would be the lower risk in most cases. You see examples of drip irrigation under black plastics, not as likely to contact produce, but I've definitely walked through produce fields that have drip irrigation lines running that have busted emitters, and it's like a rainbow. It's real pretty, you know, those little spouts of water and the sun coming down. So you can't always guarantee that that water is not going to contact the crop. But generally, if your system's functioning properly, as it should be because you're trying to improve your efficiency and really get it to the root zone, that's going to be a lower risk application. When we start getting into the agricultural water requirements, you'll notice if you look at the proceedings document, FDA has requirements, but they only apply when things are defined as agricultural water. Basically, agricultural water is water that directly contacts the edible portion of covered produce, or produce that's covered by the regulation. So in the case of drip irrigation to something like staked tomatoes, it's not likely that that water is going to actually contact the staked tomatoes, and therefore would not be deemed as agricultural water, and therefore would not be subject to the requirements of testing. Another example of that would be if you're using drip irrigation for, let's say, tree fruit. That water is not likely to contact any of those apples or any of the tree fruit in the tree, so it wouldn't actually be considered agricultural water, and the testing requirements would not apply. I just want to mention this to you because if you're thinking ahead and thinking, okay, I have been thinking about doing drip irrigation for some time now, and now these regulations are coming out. I know a lot of growers are thinking about moving to stuff like this where the water is not going to directly contact the produce, because then they can avoid doing the onerous testing that is in those requirements. So I just wanted to put that out there. But generally, if there is less contact with the produce and the water, the risk is going to be lower. You get into some interesting scenarios that I've worked through with growers where they're applying water at different points during the production season. So for example, if you're using water as frost protection for the strawberry blossoms or even tree fruit blossoms, that kind of water application probably isn't as big of a deal because you've got all that time between when that water was applied for frost protection, probably in early spring that's when you're applying that, and then when the fruit is actually going to be harvested. And if you've got several weeks or several months in between that period of when you applied the water and when you harvested, probably the risk is going to be lower. So there's some interesting situations that you come up with, but generally if the water is not contacting it, it's going to be a lower risk. The only way that you can know what the quality of your water is to test it. Bacteria, viruses, and parasites, all of those things that Jennifer talked about, you can't see those with your naked eye. You can definitely see things like fecal contamination, or if you have a ton of deer crap in your field as you're harvesting. Those are visible things that should cue you in that, yeah, maybe we might have a contamination issue here because we know that those things carry pathogens, but you can't see pathogens, especially in water. So the only way that we know what the quality of water is to have it tested. And the huge benefit of testing your water and having that data over time is so that you can actually know generally what your quality might be over time. It may be that you only have issues at a certain time of the year, like the one grower did with the guys gutting deer into his stream, Or it might be that you only have issues during migratory flyways when the birds are coming through. But you can identify trends if you're sampling over a longer period of time versus just reacting to one high sample. So this is just an example. This is some water testing results. This little red line here, it's actually geometric mean of generic E. coli. So this is kind of the previous industry threshold that a lot of the audits were based off of. 126 was the number. It's the same way in the regulation. There's another number in there that I'm not going to talk about, but generally this is what the grower was trying to meet. And you can see they were going along their testing through all these months and getting pretty low numbers, and then came July and August, they got some really huge numbers. Not huge, actually they're not that big, but in comparison to the rest of their data, they definitely knew that something happened in that case. This particular incident was actually a grower, their neighbor's dog died in the pond, and they found that dog, removed the dog, and then retested the water, and it turned out that eventually that flowed out of there. But these are the weird situations that some of which you might never catch with water testing, and other times you might. But at least you have this data to go off of to know what your water quality is over time and to help you identify risks to help minimize those from happening in the future. Those other examples that I gave you are freak incidences, but things that you can anticipate, like if you're in a drought or if you have really heavy rainfall, those might be indicators that your water quality might go down and your test results might go up. Okay, you're going to notice in the proceedings as well as on this slide, and if you go to the training tomorrow, what FDA proposed in the water regulations was this thing called the Microbial Water Quality Profile. Basically, what FDA wants you to do is take a number of tests at the start over a period of 2 to 4 years so that you can get a sense of your water quality over time. They want it to be not a reactionary, but more long-term. What does your water quality look like? And it basically has this flow of things that you'd have to do, where you take samples at the start, and then every year thereafter you have 5 more, and it's this rolling profile of data that you'd have to have on file. And I'm not going to talk about the specifics of these because, as I mentioned at the beginning of the presentation, we think that a lot of this might change, especially how many. This is specifically for surface water, but they're proposing, or they have made final, you got to take 20 samples per water source. So that means if you have 2 or 3 ponds, yeah, I see people going like this, money, holy crap. Yeah, exactly. If you have 2 or 3 ponds and you've got to take 20 samples for each of your ponds, if you know anything or have done generic E. coli testing previously, those are $30 to $50 a pop, each one of those tests. So it can be pretty expensive pretty quickly. There are some other issues with the test method that they have outlined in the requirements that it's not widely available right now. In fact, in New York, we have lots of water testing labs, but only 4 of them currently offer the required test method that FDA has put in the regulation. So there's all of these issues right now that I want you to be aware that there are going to be some testing requirements. I don't think that that's going to go away. But I think that this whole microbial water quality profile that they're asking you to develop is going to change in some form or another. How many of you are actually doing audits in here right now? A couple of you, okay. So you're already doing water testing, and I would encourage you, obviously, to comply with your audit. You will still have to do that water testing. But honestly, I would hold off on worrying too much about the water piece of FSMA because A, it's going to change, and B, there are extended compliance dates. So Wes mentioned that when he was talking. The compliance dates table is actually in the proceedings if you're interested in those dates, but every farm has 2 additional years after their initial compliance dates to meet the water requirements. And again, I don't know if that's going to change, but basically that means for most people, you don't have to have your microbial water quality profile until 2020. So you got a little bit of time. So I would encourage you all, let's see what comes out in the guidance, see what comes out from FDA and what's going to change before you take any drastic measures. So let's get back to just overall, how do you take water tests? We're going to kind of leave behind the FSMA stuff for now because what I want you to understand is, first of all, what are you testing for? The test that you want, what you want to test for is quantified generic E. coli. And as Jennifer talked about, there are some E. coli that are pathogenic that can cause illnesses, and then there are some that we call indicators. This is an indicator. How many of you have E. coli inside of your guts right now? Everybody should be raising their hand because everybody has E. coli. Not all E. coli are bad. They actually can synthesize vitamins for us, and they're really essential. But some of them, in particular generic E. coli, are indicators of fecal contamination. So it's the best indicator that we have that there might be animal poop, human poop, some kind of poop in your water source that would be indicative of some type of contamination. We don't test for specific pathogens because they're really difficult to find and they're really sporadic. So that's what you're going to test for, quantified generic E. coli. In the regulation, they outline 2 microbial criteria. The first is this 126 geometric mean, and then the 410 statistical threshold value. Don't worry about those for now. That is also something that I think might change with this regulation. What you got to keep in mind is just you need to be testing for quantified generic E. coli, and that's what most of you are already testing for if you're doing audits. In terms of actually collecting your samples, it's going to be dependent on the lab that you're working with. They should be sending you instructions for how to handle the sample, and you should follow those instructions, but generally there are some best practices. You've got to have a sterile bottle. So when you get that bottle from the lab, don't undo the lid and then just let it sit on your counter, or even rinse it with your tap water, because that tap water has chlorine in it. You're going to make the sample invalid. So make sure that you don't stick your grubby little finger inside when you're pulling the water sample or anything like that. Make sure that when you open the bottle, you open it right as you're about to take the sample, and then close it up and don't touch the rim. Something else that I've experienced firsthand, unfortunately, is if anybody's ever tried to take a water sample in July on a 90-degree day, and you turn on the irrigation and it comes out of the pipe and it nearly burns your hand, let that irrigation water run for a little while. Otherwise, your sample is not going to be representative of the actual water quality because it's been boiled in the pipes, right? I mean, if you really wanted to have a clean sample, I'm not suggesting that you do this, but if you want to have a representative sample, let the water run because that water is really hot, and then take your water sample. Something else in terms of where you're taking it depends on what kind of water source you have. If you've got a pond, don't just wade out with your feet into the pond, because what are you going to do? You're going to stir up all the muck, stir up all the sediment, stir up things that probably wouldn't have been in that water anyway. So that's why you see a lot of these people, not in this picture, but I thought I had a picture. Usually when we take water samples, it's on a big stick, so you can just kind of reach out into the middle of the pond and not disturb anything around it. If you're on a stream or a river, take the sample from wherever your intake is, wherever the water is getting pulled out and into your irrigation system. Okay, what lab should you use? I would definitely contact Western Meredith. They probably have a list of labs in your area that they could suggest to you, but generally you want to find one that has certified methods, meaning that they're providing an established method. For example, BAM methods. They're based on science, and we know that those methods are going to work to get us the numbers that we want. Make sure the lab can provide the test that you need. For the regulation, the test that they currently say that you've got to use is method 1603, which is quite a departure from what most growers are currently using. A lot of growers use a test called ColAlert, which actually gives you a reading in MPN. And we think in the regulation it says you can use other methods that are equivalent in accuracy, sensitivity, and precision, but they don't really give us much more guidance than that. And I think that's something that will come out in guidance, that there may be other test methods that are acceptable. But right now, this method 1603 is what is the required method. And I don't know in New Jersey, but there's only 4 labs in New York State that do this method.
We've got calls to make, but we know it is failing us.
Okay, that's good. The other challenge with this method at 1603 is it has an 8-hour hold time. It's actually 6 hours that you'd have to get it to the lab, and then they have an additional 2 hours to process that. So for those of you who have been taking water samples and shipping them overnight or something like that, that's not possible with method 1603. So I know some growers out west have basically form drop sites where they're having one person run a bunch of samples to try to get them to the lab there in that period of time. But that's another one of the limitations on this particular test that they have in the regulation. Again, I think this might change, and I would encourage you not to change your current test method until we have more information on that. Make sure the lab provides sampling instructions. If you don't receive them, definitely give them a call or shoot them an email. Okay, we just talked about this, but generic E. coli is what you're going to be testing for. And usually when you see your water test report, you're either going to get a reading in MPN, most probable number, or CFU, colony forming units. The test that FDA is requiring reads in CFU. So if you have MPN on your water test, it means that they're using ColAlert or some other method that's reading an MPN. So that should be a kind of ding, 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 this might not meet FSMA requirements, but again, I'm not sure if that's going to change in the future. Okay, I wanted to go through just a couple examples because what I find is the growers I work with take the sample and then never really look at the data until the auditor comes, and then they realize that they've got big problems. So let me give you a couple examples of some water tests that I've worked with growers through, because they called me and they're like, what does this mean? You have to have a number, like one number on your test readout. It can't say greater than, it can't say less than, because in order to calculate the stuff for the regulation, it's gotta be a specific number. So make sure that you're doing a test for quantitative, meaning you want a number, not presence absence. If they say, yep, you've got generic E. coli in your water, that's not really helpful to you because how much do I have? Is it really a big issue? You need to have a number. So if you see something like greater than, less than, or yes, no, or presence absence, you're not asking for the right results or test. So make sure you take a look at that.
Would an MPN be recorded less than 1, or you recorded negative?
If it's less than 1, you can assume it's a 0. And that's an appropriate thing to do. But if it's something like this, like less than 8,000, that doesn't give you any reading. It just really doesn't give you any indication at all. Okay, some other things that I typically see. So this is another example of a water test. And here you can see, you can actually look up the accreditation to see if it's a certified lab. And that should actually have paperwork that you could ask the lab for. I have had growers who have gone through global GAPS audits that had to provide the laboratory service certificate. So that's something that just to keep note of, you might want to have that certification number on the actual lab readout. Other things, the actual method. So this one was EPA 1603. You want to make sure that for the regulation you're doing that test. The other thing is the time, the sample time, the analysis time, making sure that for 1603 it's got to be processed within 8 hours. So if this time happened to be longer than 8 hours, the test would be invalid. So those are some challenges again with method 1603. Also, you want to have a number. You don't want to have a less than, equal, or greater than sign. You got to have a reading. Okay, so what can you do if your water tests don't meet those requirements in the regulation, or you're getting high test results? There are 3 main things that you could consider doing. The first is apply an interval for die-off. The second would be re-inspect your water system to identify problems, and then the third would be treating your water. So let's talk about this die-off. We know, Jennifer talked about, pathogens die off over time. What you're looking at here is basically bacteria, generic E. coli, salmonella, a bunch of different bacteria, and how long after they were applied to the crop did they die off. And you see that over a period of days, you can have die-off, but you end up usually with this tail that goes out really long. And sometimes it's the tail that we're worried about. And some of those pathogens might be on there until the time that you harvest the product. There are a number of things that can cause this die-off. Can anybody think of what could cause bacteria to die off in the field? Temperature, yeah, really hot, really cold. Sunlight, UV rays from the sun actually can cause die-off. What else? Humidity, or the opposite, you have desiccation or drying from a really hot, windy day. So all of those things can impact whether things are going to die off or not. The thing that I want to pose to you as growers in your decision making is, If you test your water and you get really high, let's say you get 4,000 CFUs of generic E. coli, and you're gonna say, I'm just gonna wait a couple days because I know that bacteria generally die off half a log a day. Is that really gonna take care of the problem? And from a scientific perspective, we do have data that says, we can anticipate this amount of die-off over time, but there's always gonna be conditions, the humidity, maybe there wasn't that much wind, maybe it was really cloudy, that I can't guarantee that there aren't pathogens hiding underneath the leaf, in the stomata, in places that no sanitizer is gonna be able to get at. So that's gotta be up to you. If you know what your water quality is, you gotta decide whether just waiting to harvest the product is gonna take care of the problem.
Do you wash it in sand or spray off something on it to kill it?
So there are sanitizers, and there is research, lots of research that's been done on removal of pathogens from addition of sanitizers in wash water, but it's not always 100%. You can't guarantee that it's always going to get it off, and usually most sanitizers are just used to prevent the cross-contamination, like the spread throughout the water. Once it's on the actual produce, it's really, really difficult to remove. Think of like the netted rind of a melon or all of the folds of romaine lettuce. Once it's in there, it's really difficult to get off. So the second thing you can do would be re-inspect the entire water system to just check and make sure, see if there's any dead legs or if there's some sort of introduction of contamination. There may be something in there that you didn't realize is contributing to the issue. Or you could treat your agricultural water. So there's a number of ways that you can treat it. UV is one of those ways, but UV systems are pretty expensive, and some of them can't provide the throughput or the volume of water that a lot of growers need. I know a lot of growers also use filtration units, and there's been some mixed research on those. We had one collaborator who actually saw spiked higher counts of bacteria after the filtration unit, which is indicative that something's going wrong in the filtration unit. But there are other options. The issue with chemical treatments for production water is that they've got to be approved by the EPA, and they've got to be used for human pathogens or E. coli. I can tell you right now that there's a lot of products on the market that will control plant pathogens and other types of spoilage organisms, but aren't labeled for use in field for human pathogens like E. coli. So keep in mind that whatever product you're going to use has to have an EPA label. I think the demand for those kind of products is going to increase, especially as people realize how crappy their water quality is. They're going to want to treat it. But you have to think any type of chemical that you're going to put into a pond or some type of open water source has implications outside of just treating for pathogens. You have environmental considerations, water discharge issues. So think about that as well. Spot to bring that up. So for the regulation, it says that your water test has to be representative of the use of the water. So if you have a treatment system, that water that comes out after the treatment is going to be representative of what contacts the crop, right? So you're going to want to take your samples after it's been treated. But you still have to, we still believe that you still have to treat it or test it. So what I'm getting at with a labeling issue is that there aren't products out there right now for use in production water systems that are labeled for human pathogens. But if you're talking about filtration or UV, absolutely take the samples after the treatment. You could still take them after your chemical treatment, but I'm not aware of any chemical treatment right now for production water. But as far as we know, we're working on a project right now to look at other products right now that are labeled for human pathogens. So that's all I have for you on water. I really recommend that you sign up for our general listserv. The Produce Safety Alliance is producesafetyalliance.cornell.edu. And whenever we get more information about what's going on with the ag water standards, whether FDA is going to change them, what's going on with guidance, we send all of that stuff out through our listserv. So I really, really encourage you to sign up for that. I only do about once a month newsletters, and they're all related to FSMA and produce safety. We also have a ton of really great resources if you're interested in going to other trainings that our collaborators around the country, including our collaborators at Rutgers, all of that's listed on